Hello everyone, welcome to another tutorial in this Kubernetes series. So this is also a very important tutorial, which is that how you can schedule stuff. So by schedule, I mean, let me just show you what do I mean by schedule. So definitely, so there are some stuff today we are going to discuss. First, what is the agenda today? Today's agenda is to check that. On which parameters a scheduler actually select or deploy the resources on different nodes. So as you know that we have been discussing a lot of stuff when it comes to the architecture of the Kubernetes and stuff like that. So the basic revision, just a 2 minute recap, is that there are master node, there are worker nodes. That's how you distribute your cluster of your Kubernetes. Kubernetes has different component which is installed on each machines. These component are doing stuff what they are designed for, and this is the beauty of Kubernetes. So, what are those components? API server is the main singular point of communication. By single point of communication means that every communication happen with any worker, and master node is going through or any kind of task which is scheduled or whatever is any task assigned to or has been done by any cluster is going through this API server. API server is the single point of communication for Kubernetes, and then some components are like kubectl is the engine or the main program that actually handles stuff. Then network proxy is something that networking. Calico is the plugin for that, and then we have seen that there are etcd, which is storing database, which stores every state and everything of those all nodes and all the tasks. So in between, there is another thing that is called scheduler. Scheduler has also a very important task to do. This scheduler is also very handy in doing some stuff for the load balancing as well. So load balancing is a big task and big topic in world of any container or orchestration or any Dockerization or any runtime engine Dockerization, because load balancing, vertical, horizontal, whatever it is, as automatically scale your services. And then comes services itself. So that's how the Kubernetes services. So this is the short recap. We have covered a lot of stuff already. You can go in the complete playlist and you can check the previous video, like whole DevOps stack as well. So let's start without wasting any time. So here is the node selection stuff. So one thing comes in your mind that how actually you select the node. So it is very simple. I'm going to show you practically. I just go to master here and I say kubectl, kubectl describe, and then nodes. And there we have description of all the nodes attached to it. We have in fact three nodes. But if you scroll a little bit up, there is the conditions. What does that condition means? That simply there is an underlying process in the Kubernetes that checks regularly that which node is has what available resources and what is doing. So very simple stuff. It is important for any Kubernetes scheduler to check the health, that how good his worker are. Are they able to really get the burden of work or not? Do they have available resources and capacity or not? So similar. If you see here, this is network availability, that if the work is work network, local network is available or not. This is the number one criteria. And then memory pressure, disk pressure, PID is nothing but a processor running on the logical ports of any processor. And this is the PID, and PID is also very important. If any node is heavy on the processing side, this is also not a good sign. And here the end status that cube CTL is good now. Network wise, here is the Calico, which tells us that Calico is the network's proxy configuration module that is running and that is responsible for doing network and a lot of other stuff here. So very simple, great. Now let's do a practice that how you can select, or you can say that please for some reason. For example, the use case could be many different, but here we are learning all the possible and industry standard most important features which are mostly needed or might be needed in the industry. That is our focus here. So this focus, keeping in mind this focus, these are the anyhow main important different styles of selecting nodes. The very easy stuff, which that you can just give a node name that please deploy any pod, any services, whatever, any replica set, whatever replica control, please deploy my resources on this node only. You can say that. And well, this is kind of easy. And then there are some more advanced topic given to you with respect to complexity as well, and with respect to the use case as well. And these are the node affinity, pod affinity. Pod affinity and node affinity are doing pretty much same, but there are two different for the node one, and one set is for pod level. And anti-affinity, affinity, and then taints and tolerance is something that talks about the restriction of this stuff, where you can go, where you cannot go. Let's now discuss them all one by one and see them practically. Okay, let's do it practically how you can do it. So here we are in the node name. So let me just walk you through this. What is this and how that works? So here we are, for example. Okay, here we are. So we are just go to the API because the kubectl is working in the API style, as you know already. And they have some endpoint name. So this is name deployment, which is nothing but it means that we want to deploy something. And deployment also, you know, that works in the services way. So for every kind of deployment, we need some services to create. So we are giving metadata to it in the specification to the service. We are saying that we want to create two nodes, and this is the selector. So the selector means that please match label and match label. As you can see, this is the node replica style, which is the updated version of the node node replication, right? And it says that please go and check if any services in it go and check if any port, because essentially of course in any service there are some ports are living, and please check the name of the port. If it is kubeserv, select is as a replica. Okay, cool. Replica is nothing but replica means that number of different ports. And how you select the ports, the selector, which is very necessary that you need to have some criteria to say that what ports are already created and what new is going to create it on which name base we have discussed this in very detail previous tutorials. And templates is something that segregates the top and bottom. And top means that everything here we are everything every declarative we are writing here is talking about the service itself, like deployment itself. When we talk about the template is the keyboard for the Kubernetes, because Kubernetes thinks after the template whatever is written are meant about pods. Great. Now we go to the pods and we again create the labels. That's everything is as usual. If you are following our tutorial along, so everything is standard, nothing new. And in the specs of the template of the label node, we can give here that please deploy this node to the node number 2. That's the only thing. Other than that, everything in under the specs is same. Container image, everything remains same. The only new entry we have added here that we can add it as it is. So let's try to implement this. Well, great. Kubectl. Mm. What was the entry again? Now I am not sure that what is the name of my node here. I could go here and I could say sudo kubectl get nodes. Okay, and the node name is the control pinner, where the control pinner is. This is master, it's the VM. Let's prod. Let's oops. Let's go on. Okay. Then if I list here, not new, nano, node, level, and here we are saying this is the prod. Yes. CTL IF node name qctl get all. Okay, what's this file is carrying? This file is carrying deployment inherently carrying the replica set, which is 2, which we have mentioned, and it is trying to create the deployment of the app with the name of kubeserve, and is also creating the service additionally in the background, because every deployment inheritedly required already the kube service and the replica set, which is nothing but a number of node you want to run across. Okay. And how do we know that where they have this? So we can kubectl get pods, and we can see that okay, the output should be void to check this, and now you can see that the port is automatically configured to the port we have, because we have given that please deploy our services to the pod specially. So which means, so this node name selection based on the node name, that's how it works. Great. There are some other ways which we are going to see shortly. What are those? So the most important, or let's say a little bit more complex, but yet very important, is the affinity, anti-affinity. So which gives you a lot of flexibility and rule-based and expression matching. Based on that, you just can filter a lot of code. So let us just delete this service, or if we delete the deployments, then it's automatically delete everything else. So this is the good thing. Let's delete the deployment. kubectl delete deploy. Deploy is the short of that. And the name of API is deployment here. From this name before the slash, you can easily see that which name it is, or which service it is, or which API it is. This API is deployment. Cube. Oops, spell mistake here. Kubectl delete cube data. Oh my God, this keyboard is actually, very slow. Sometimes press double, sometimes single. It's very sad, but yeah. You get the point. We can delete it. And good. The next topic, which is relatively straightforward, node selector. You could just give the label to different node selectors. So I can draw something actually right here. Have this pen maybe speak bigger about. Okay, we have, for example, different nodes, and we could have different labels. So, for example, in our cluster, we have this four node. What we can do is that we can segregate them or label them. So, yeah, labeling is very effective. And why we label them? We label them to separate them for different use cases. For example, here we have environment. I could write as to environment is equal to dev here, for example, and this one is environment is equal to dev here, and this is for production, let's say like that. So first we check everything on the test environment, and if everything works fine, we just pull it to the prod actually, and that's how, for example, it is our philosophy or it is our strategy. So that first, please create this, and yeah, then, for example, segregate them. Now, what happens is relatively very simple. How you can achieve this? You just go to the master node, which is somewhere here, and you just say kubectl get nodes. That would give you a node. For example, nitro is our node, which we want to specify for test purposes. What I can say is the kubectl. Then, for example, I can get the sources of label. What I want to give label nodes. Which nodes? Nitro. What we have written here, environment is equal to dev. env is equal to dev. So this is our label, right? This is our label right now. And kubectl get node. Maybe it's, is there anything into the node? What is it to fight? Great, I had to kubectl inspect, not inspect here, describe node nitro, and in the node nitro, I should have somewhere label. Yeah, here. So the label is apparently showing here. There are many label used for different purposes. So for example, we can use a different label, and internally it's also the Kubernetes cluster itself is also doing this for its own his own software, for example. They are using the system level nodes as well for the labeling purpose for do the same. So great. Now it is kind of very simple now. We just go here to the same YAML file. Everything remains same. In the specification of node, we can give label, right? Just selector node, for example. Okay, this is stuck. Very beautiful. I don't know now what to do. It's not giving me prompt back. Okay, when then we can do nano and selector nodes. Selector nodes is easier. We can just paste it, and it's very simple here. We just say that now the okay the now the important thing is that how you could give the name here. Mm. Yeah, is equal to def. That's what we have given, right? Just confirm it. Okay, environment is equal to def. Yes, save kubectl apply file selector. I we have given it in YAML or not? Mhm. Yeah. Okay, the thing is that might be we haven't name our file here in YAML, which is sad. We need to name it as dot YAML actually, and then only it works. YML kubectl. Uh, I have restarted it and it's not working anymore. Um, swap of all. This is the another problem for the virtual machine that you always have to clear your swap. Okay, swap is clear. So I have also described many times in the tutorial that for the virtual machine you need to clear the swap. You can make this permanent in changing the configuration file, but I'm not doing this because I'm a bit lazy. But every time you restart or start your virtual machine, you need to do this. Otherwise, this is not going to work for you. Okay, now kubectl apply selector node, and since we have said that our nodes are only pods are only going where the label of um, pod is label of node is given as environment is equal to def, which we have made sure that we have label over node. And now let's see kubectl get pods. Output should be void. My God. CTL always. Okay, here you can see now that node selector is automatically active and it's only going to nitro. One thing you need to make sure that um, you have given your label in the way that environment is equal to sign and it is def. But when you're writing it here, sorry, cat selector node, and when you're writing here, you should write in this way. Inf is whatever name of label first key, and in the value, like after this colon, you write in the inverted commas for the labels because label is kind of string thing. So it is better to always give a label um name in this way. Great. Nothing fancy that we have done. Now let's delete our service kubectl get all, and then we have one deployment with two nodes, and let's delete it. Kubectl delete. What we want to delete? We want to delete our deployment. Name of this deployment is kube surf, and it is deleted now. Okay, it's trying to terminate these pods. As we can see, this is the pod. One service is running, but that doesn't take much memory. So we're good to go. Here we have label over pod 1 is in dev environment. Now let's try to grasp the concept of affinity and anti-affinity for both for the pods and for the nodes as well. So this goes for the both of the concepts. Okay, the next possible and little bit more complex option is the node affinity. Node affinity, I guess, is nothing but so let me just give you an example. For example, for the node selector node name or the key value pairs, what it is doing, it's a very strict and hardcore condition. If condition match, great. If condition doesn't match, what happen? So actually, you think this concept in this way that Kubernetes is built by world top technical people, for example, Google, and they have been doing this or improving this for years, which means that they have seen this or they have feel the need of the option and then they try to develop it. And everything has a need in the background. So, and the use case in the background. So the thing is that you could imagine that, well, a node selector, if you're giving the condition that, okay, if the key is equal to inf and the value of that key is equal to def, just go in the label file and label list and match this. But my question would be that what happened if it's not fulfilled? For example, any container is, you're fulfilling any container. Container is trying to go here, and the inv is equal to dev. So there is no label match, go here's no label match, go here's no label match, and here's no label match. Then what happened? For example, it could be by mistake that you write a typo in the YAML file in the invisible to dev instead of dev, you'll write a dev one. Then what happened? So in these cases, you should have some more complex use cases, which is node affinity. And now node affinity says that you could do the selection on different bases. The first base is that you really have some margin or tolerance or some flexible way try to put the node here, here, here. If everything fails, just put it in maybe in different node if it is available, or any one of the node if it is available. But the thing is that when you try to implement some level of flexibility, of course, there is some cost. There is something you have to give way. So what is the cost of that? The cost of is that you cannot exactly achieve what you want because, for example, your preference was to achieve this on dev environment, but due to some reason, your second priority is also that you don't want to completely miss this pod. You don't want to run this and stay in the pending state. This is also kind of not very charming and not very good that you just put this into the pending state and your purpose is not fulfilled. That's why there is the mechanism of preference all the time, and mechanism is of preference is very beautiful, which says that 80% preference you're giving to the condition one. If doesn't fulfill, give the 20% condition to the second affinity, whatever condition is there. And if nothing fulfills, then just at least, for example, you say that required or preferred. Required or required or preferred. And what that do, that really are two again kind of more control knobs, which give you the opportunity or give you the possibility that do you want to exactly achieve this condition, or you're still more flexible into it. What I mean by that, let me just tell you that. For example, you are giving the 80% condition that if the in is equal to def, please go there. Then you write the second one that this the second condition is condition one is equal to, for example, environment is equal to def, but you also give 20% condition that even for some reason it has failed, the environment is equal to test, please do that. And now the 100% conditions are fulfilled, but somehow, sometimes, maybe it is the case that after exhausting all the condition, you're saying, okay, this is enough flexibility. I have given the three conditions, 1, 2, 3, 80, 20, or 50, 20, 10, whatever the combination, you can split or you can split this percentage into maybe the 10, 20, whatever you want this percentage as per your requirement. And you're saying, okay, I'm kind of bit touchy on the environment. So my main use case is that it should be go to the proper environments and not any other nodes because other nodes are reserved for some other tasks. And I only want to deploy these node, whatever I'm writing here for the people to just test and develop this stuff. And I really don't want to go it in the prod, which is makes sense that you don't want to push something in the prod, of course. And then, yeah, that's the thingy that you don't want to send it into the pod. And then you say that if you, what I mean here, I will just tell you that why I'm telling this story, does this required and preferred and where it is used. Sometimes you can also say that, okay, if all the conditions of this label is not fulfilled, then stop it. Do it in the pending state. Why? Because I'm not more flexible. I'm flexible to the weightage 80, 20, 10, but I'm no more flexible and please throw it into the pending state. But if you say preferred, if it always schedule your pod at least somewhere. If you say required, then if it's try to follow this your preference percentage, and after that it's because you said required, it's push into the pending state. So this is the mean by that, and there is one filter or specific name you would always see into this affinity section. Preferred during scheduling, required during scheduling. So let's for now I will explain you this part later on. This part I will again tell you that what is mean by during execution. This is not very important right now. But for example, I'm saying that preferred during um, scheduling. Preferred during scheduling is something very important for the affinities. Preferred during scheduling means that you're saying that, well, I want to prefer it. Why? Because if everything is still not, um, so you want to just, for example, put it here, 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 nothing fulfilled, and you say here this preferred, and it still put it into prod in somewhere. Great. But if you say here the required, then it's try to find relevant key value pair, key value pair, key value pair here, 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 nothing matched. And then because you have specially instructed is a required, you're filling sometime a form, and in form there is a static given. It means that it is a required field. If you don't give name, it's always complain you please give your name, please give your name. And this is same here with the required, because you have said required and try to find nothing, then it's just drop your nodes completely. Hope so that it's now clear. It shouldn't be a very complex. Now come here just and then see here. Nothing fancy, same thing deployment. We are now we are giving the meta name preference, and then selector is about prod. Mm, replica is also about ports. And here, affinity, scope of affinity is not node, but it is about node, because you can also give somehow the this preference mechanism to ports as well. But the most important is node, because it is somehow need for scheduling, right? And you when you go like more sub level, you can also say dash weight here is 80%, and in the 80% preference, you are whenever you write this dash, it means that after that, whatever written is again under this umbrella, under this tree. So this is sub level of tree. In the sub level of tree, you are going that now my preference is a match expression, and match expression is nothing but what it will practically do, it will practically just see the key and value. Whatever is before the equal sign is key, whatever is after equal sign is value. You can also give multiple value to the keys. For example, I can also give two value to the zone east, west, north, south, or I can only give the value one, right? And whenever you give to the label to the ports, we have seen this, we can give label here, right? In the master, we have seen you can just give always label, right? And the how you give cube CTL and label kubectl services label node, to the node I want to give label. And for example, nitro is equal to uh, I want to give label to nitro. And what label I want to give, let's take it one from here as well. Okay, the 20% weightage is for the web, and the key is type web, and I can give then type is equal to web, type is equal to web. Now this is key value pair, right? This is just key value pair, right? The label is given, type is equal to web. Whatever is written before equal to sign is key. Whatever is after equal sign is always value. And you can also write it in any kind of your node selector in this way. And the same is true for all type of selector. Uh, we have seen many selector type and many match expression and many matches in also different services as well. So two different. So this is applied for all the services in the Kubernetes. That before equal sign is key and after is a label. You can put inverted commas. You can also not put inverted commas if you're writing in this style, because in the node selector because we were just node selector, we were just one level below, and that's why we put here, like for example, inverted commas. But we also could skip the inverted commas; it should still work. And because this percentage is kind of more, complex here. By complex, I mean the conditioning is a little bit more complex, and that's why we are two weights, 80% weight, and under the 80% weight, the key is the zone. One key should be one, value could be multiple. Here, like, and that's why we have multiple values. Then we can also give here operator. So what is mean by operator here? The operator is nothing but gives you multiple options. It says that go to the keys and key is this. If the key is zone, and then search the all the list of possible all values, west, north, whatever list is this. And if any of the key, any of the value of the key, east, west, found in this list, that's why this operator means if you found any single thing, then please consider it as a condition fulfilled at the preference level of 28, 80%. This 80% is very important because first conditions. So that's how. Let us just, because we have created web, because the weightage is minimal, and this is also a very good option for you to show that if first condition is not fulfilled, it's going to the second step and third and so on. And since we have already labeled, let's copy this service. Let us just delete everything. Cube CTL get all. Oh my God. Cube CTL get all. Okay, one service is running. This is a good thing. And kubectl. What we can see that no. We can name it affinity.yaml. In the affinity.yaml, we can paste it. Okay, image v doesn't care anymore. Type, okay, type is equal to web, 20% weightage. We already have done. And this I have shown you the preferred during scheduling. When we write preferred, it means okay, please give the preferred. But the thing is that please do not uh, throw my pod into the garbage bin and throw it into the pending state. At least schedule it sometime, but please give the preference to all these parameters. And if you write required instead of preferred, it means that no matter what, I'm stick to my conditions. If none of the condition fulfills, please put it into pending state and don't schedule it anywhere and don't run it. So this is with respect to the that, and then ignore during execution means that once something preferred, once something is scheduled by the scheduler in the services, then if you change the label at the last moment, for example, I just hit enter, apply enter, and it's scheduled automatically, but port is not yet ready and nothing is executed. But in between, I very quickly change the label, and during the execution, it then ignore because something decision has been made. So uh, ignore during execution just mean that not very difficult. Kubectl apply apply YAML file, apply affinity YAML, and your preference, your deployment name with the preferences created. And now you want to see that my pod where my pod is schedules. Kubectl get pods. Output must be wide and kubectl get pods. See why I'm spelling kubectl a lot. Get pods and then pods. output is equal to void. And since the 20% weightage we have given to the nitro, and if I kubectl describe node and node is nitro. Sorry, voice automatically kubectl describe nitro. Oh my God. Kubectl describe uh, what you want to reports nitro. Nitro. This is not multiple ports for the single port. We don't have any nitro. NIGRO. kubectl describe port nitro. kubectl. I now forget completely. Okay. Okay. We should see nitro somewhere. Okay, here are the label. Name is the nitro. Label environment type is equal to web. Now, as you have seen that 80% preference in the file was given to something else. The 80% weightage was this one. To the operator key values the east. Only 20% was this one, but this has failed, and your port has been scheduled, as you can see here, onto this node. Nitro. You have seen that this is in where it is nitro here, and that is the reason because it was in nitro. The reason was very clear because as you have seen that this is the reason because it matched the 20% conditioning. So that's what the affinity means, right? Which is the most popular and most widely used parameters. And then might be I'm able to tell you another concept which is not that much of importance, but still it is important. Everything is same. And mm, you have toleration, right? Now let me just give you another example, practically, which I could give you the small conceptual overview of the tent and toleration. Tents and tolerations. Now this tent or tent, TAIN, tents and tolerations. Tent means color, and for example, now let me just take an example that I have this node. This node is red node. Then I have yellow node, and then I have green node, right? Now for the red node, why I have this red node? Let's say like that for the system level configuration or some important configuration, I want to reserve this node. This node is now, for example, kubectl nodes taint um, node is tainted, let's say like that. So we give a command and we taint this node. Why we taint this node? Because we don't want to run any operation in this node because this is completely reserved node for some reason. And these nodes are as usual, normal nodes with respect to different color scheme. Yellow is okay. The second important node for some system level resources, but still it's okay to run other resources too. But green is just common one. So this is our scenario. But sometimes you have this color scheme, which is great. But sometimes what happen is that you really want to give a toleration. By toleration, I mean that you are saying that this node is strictly prohibited, but if I give some toleration to this, okay, please, if you find nothing to schedule, then please go ahead and schedule this here. Now, what's happening here is that in the tent, let me just give you a very basic example, and then tent will be completely clear for you. For example, I have tainted this, and why I have tainted this, let me just tell you. This is GPU base GPU instance. This is GPU instance. This is CPU instance. This is general purpose. So you have some workloads. You have some workload, for example, now this is the age of AI, and for some application AI, you always need GPUs, and you don't want to waste your GPUs for the task which are not GPU intensive. That's why you have divided your nodes with respect to the colors. What color? Tint. Now tint have some effect. Whenever you write something how you tint, you just go there and you say kubectl tint node maintenance node, tint node, services tint, and what tint, what you want to tint, node you want to tint, and the key is you can give it the key to the. Okay, let me just give you a bit. Forget what I said. There was some other concept. So, for example, I go there, kubectl tent, tent is service. What I want to give node, GPU node. This is kind of label we want or key I want to give to the my instance GPU node. And this is name of my tent, GPU node. Yeah, this is what I want to give. Every tent has name. And GPU is equal to true is the kind of label way, or GPU equal to true means that if the GPU is equal to true, then please no schedule. So this is the complete key value pair of the tent. GPU is equal to true. If the GPU is equal to true, no schedule. Effect is equal to no schedule. Normally don't schedule anything. And this is the condition. For example, now all the taints are given to the nodes. The taint is the color which you give to the node. And the toleration. Now, very important combination is the toleration. What does toleration says? Toleration says that I could bypass, if I simply write here is that please bypass this, which means that what I want to bypass key GPU and value, I want value true and effect no schedule, no schedule. This is what I want to bypass. This is I want to really bypass. This is what I want to bypass here. And when I write this toleration in my notes, simply it's just bypass it. And this is going to be now um, a schedule here. So that with the toleration is always applied to the ports. Why? That you have colored some of your nodes already. This is red color, this is blue, and this is green based on your tent. And based on your tent, you describe the effect. All the red color or all the GPU node, uh, this could be here color too. Now this is GPU is equal to true. This could be a color is equal to green, red as well, no matter what it is. And the effect is no schedule. Schedule, no schedule. You taint some of your instances. Now in the toleration, you can bypass this style toleration. Why? So that if all the nodes, all the ports which you want to create it has GPU intensive stuff, you can just simply bypass them and run them on only GPU. And other than that, it's good. It's going to schedule anywhere, doesn't matter. So this is the practical use case. Now let's see how you can achieve this. You can just, I'm not going to do it practically because it is just same as other stuff. You just copy this file here, and in the deployment, you go there, and in the specification, you first write toleration, key is equal to color, for example, operator is equal to, and its value is the red. If the value of your taint label, because when you write toleration, then it's always automatically understand, oh yeah, you're talking about taints now because you write tolerance. And if effective is no schedule, then please bypass this. Bypass this. That's how you bypass it, right? Please bypass it, and you only write that toleration to the into the ports which you really want to do, like you want to bypass the restriction of tint. Otherwise, your restriction will work. You're happy. For example, here in the case of GPU, everything has CPU. Every port needs CPU operation. You're happy. It's going everywhere. Great, no problem. And you have some other match selector. You have selector whatever label, blah blah blah. Sometime I mean practically, to be very honest, you use both taint toleration and the selector nodes, affinities, match labels. They combinedly do this stuff. For example, normally, if for your restriction, if you have given your red, I have your red port, you have given the label, for example, GPU. And normally you just write that if the GPU is equal to true for all the ports which need GPU, or otherwise you'll write CPU is equal to true, and they are just distributing, working fine. And some of your task needs GPU, and you understood, oh, okay, that need GPU, but normally what I could do, or I can change my structure of my port and I write that it is true. Rather, I just, this is temporary stuff. I don't want to make it more often. It is just today I need GPU. Let's tolerate it. Let's do not change over the YAML files and over structure and whatever standard documentation we got in our organization, but just write this toleration and it will bypass it. So as a temporary solution, because you need today a GPU and you write toleration and it goes and it's doing your task. Other than that, your routine work is normal based on label, based on selector. It's working fine, no problem. That's the real use case of this port placement, and this is the component which is doing this is the main component which is responsible as scheduler, and under schedule you have these much stuff. So now hope so that you have cleared this whole concept of nodes, affinities, some other options, and taint and toleration. This is kind of really important for the customized and very efficient scheduling. Thank you very much. Stay tuned, and we'll come up with the next tutorial where we'll discuss something more advanced in Kubernetes world. Thank you very much. And if you think that it helps you understanding something and add some value to your knowledge, please hit like button, subscribe my channel, and thank you very much.